In this video, we're going to take a look at how we can modify the hub to introduce AAA authorization in combination with FlexVPN in order to push out policy out to the devices who are connecting to the hub over the VPNs. Let's begin. FlexVPN is intended to be the one-stop shop for iOS VPNs. And in the past, one of the things that we had with IPsec VPNs was something called mode configuration. Now, this goes way, way back. And what mode configuration is this? Let's say we have a server, a VPN server, and we have a client like Bob or some other device that's initiating a tunnel over to that VPN server. So of course we have the elements such as the negotiation of the policies, the methods of authentication, the actual authentication itself. Now in the old days, if IKEv2 was successful before the IPsec tunnels were built, that's when this mode configuration would happen. And mode configuration could push down policy down to Bob. For example, things like the domain name that Bob should use during his time on the VPN connection, or the IP address that Bob should be using. And the IP address could be taken from a pool over on the VPN server and dynamically assigned to Bob. Parameters like split DNS, which allows Bob's computer to use certain DNS for traffic that's reachable over the tunnel and other DNS for traffic that's reachable not through the tunnel. So if we want to, we can go ahead and tell our iOS router running FlexVPN that it should take that role of acting as a FlexVPN server and be able to hand out those attributes to the devices who are connecting. Now in our last video, when we left the network, it was configured as a hub and spoke. So as a reminder, we are using a dynamic virtual tunnel interface on R1 and static tunnel interfaces on each of the spokes. So the VPN currently looks like this. And R2, R3, and R4 are all using IP unnumbered for their tunnel interfaces, pointing back to their loopback 0. Now to have R1 act as a server and push this policy down to the clients, we're going to add a few components on the hub. We're going to create a AAA network authorization method list. And the method list could point to a AAA server, for example, a radius server, or we could point to the local database. Or we could use the keyword local, which refers to the router itself. We're also going to create an IKEv2 authorization policy. Now there is a default policy that pretty much is wide open. And we could either customize that default authorization policy, or we could create a new one. And in that authorization policy, if we're handing out, for example, IP addresses to our VPN clients who connect, we could specify the pool, which would refer to a local pool on R1 that has a range of addresses that we could hand out. We can also push out to our clients a list of networks that are reachable. Now in the early versions of FlexVPN, that was called the subnet-ACL. So if you're running on a fairly early version of 15.x, that would be the parameter inside of our authorization policy. However, the current way of doing it is with the command called route space set access list, and then the number or name of your access list that's specifying those networks that are reachable over that hub. We could also push out the split DNS information. We could push out a banner message, which in our case wouldn't make a lot of sense for our spokes, but if we had a remote access IPsec VPN client that was connecting in, and we wanted to push out a banner message that the user would see, it's all possible as part of our IKEv2 authorization policy. For our demonstration, we're going to create a local pool of addresses, and then we'll hand those out to our clients, the spokes in this case, so that each of the spokes, when they're negotiating, will go ahead and receive a negotiated IP address that they can use on their tunnel interfaces. Now to make this all work on the hub, we're going to take that authorization policy that specifies, for example, the pool or the split DNS or the banner, and we need to tuck that in to our IKEv2 profile. And those are the adds and changes that we're going to do to the hub to make this possible. Now to demonstrate that it's actually working, we're also going to go out to the spokes and we'll tell the tunnel 0 interfaces, hey, as far as an IP address, don't use IP unnumbered on your tunnel interfaces. Let's go ahead and use IP address negotiated. And then we can verify that the pool of addresses on the hub are being used and negotiated to assign the tunnel interfaces on each of the spokes. Before we start adding new configuration, what should we probably do on an existing topology? If you're saying, hey Keith, let's verify the basic connectivity before we start adding new stuff, I would absolutely agree. Let's do that. We'll do a show crypto engine connections active, and let's just verify what we have in place. We should have 3 IKEv2 tunnels, one between us, which is R1, and R2, R3, and R4. And then we have our pairs of child SAs between us and each of the spokes as well for the IPsec. So that part looks great. If we wanted to take a closer look at those IKEv2 SAs, we can do a show crypto IKEv2 SA, and those all look terrific. If we wanted to verify routing, we can do a show IP route. I'm using OSPF, and we should have the 10.22 3.3 and 4.4 subnets all learned, and we do from R2, R3, and R4 respectively. So the first thing I'd like to do is let's create a local pool. And the syntax for that is IP local pool. You give it a name that you want to name it, and then you give it a starting IP address and an ending IP address for that IP pool. So in this case, 172.16.0.100 through 172.16.0.200 is the range of this pool called flex pool. Now at the moment, this local pool of addresses, it isn't in use. It's just sitting there. However, what we can do is we can take this local pool and we can link it inside of an authorization policy, and then link that authorization policy inside of an IKEv2 profile. Now to do the client-server game, we need to turn on AAA new model with the syntax AAA space new dash model. And because at the moment I'm not connected to a remote AAA server such as Radius, I'm going to go ahead and create a method list for authorization for network access. The syntax is AAA authorization for network. I'm going to name it author-list so that when we see it, we'll know, oh yeah, that's our authorization list we made for network access. And I'm going to call upon the local router, meaning I'm not going to reach out to a group of Radius servers to ask them their opinion. I want to do it all locally. In a large environment, we very likely would use a Radius server as a central clearinghouse for that authorization. Now this method list, a lot like the pool, aren't very useful until we apply them somewhere. Now there is a default crypto IKEv2 authorization policy, and if we want to see it, we'll simply issue the command show crypto IKEv2 authorization policy, and that would show us all of the existing authorization policies on this router. Now at the moment, we only have the one, which is the default, because we haven't created any authorization policies. And by default, this policy is willing to accept any routes that are learned from the spokes. And it's also willing to advertise any directly connected networks to the spokes. So we could create access control lists that identify the networks that we're willing to share or that we're willing to learn. And we could apply those with the route commands inside of an authorization policy. However, the default is not having any constraints. It's willing to accept any routes. So for our demonstration, let's go ahead and tweak the default authorization policy. And to do that, we'll use the command crypto IKEv2 authorization policy default. We should get a little warning saying, hey, you're changing the defaults. And let's specify that the pool is flex pool, meaning that IP local pool. We're going to use that to go ahead and assign IP addresses to VPN clients who connect to us. And it's very likely you're familiar by now with the warning regarding changing the defaults. If something else was using that default policy and we modified the default, our changes are going to affect that other portion of the configuration. So just be aware of where that's being used so that we don't inadvertently break some other part of our configuration. So in our default authorization policy, we now have pool flex pool as the single parameter that we're going to push out to the VPN clients or devices who are connecting to us. But you know what, just for fun, let's go back into crypto IKEv2 authorization policy default configuration mode, and let's use a question mark just to give you a sense of all the things that we could change right here. So DNS information, there's the banner message, there's the pool that we're about to use. Here's the route command, for example, which routes we're going to advertise. Split DNS, Windows Internet Name Service. So in our authorization profile, the only parameter that we specified for this demo is the pool, the Flex VPN pool that we're going to use. Next, let's go ahead and modify our IKE version 2 profile called IKEv2 profile. And this is the IKEv2 profile that we created together in our last video. And all we're going to do to this IKE version 2 profile is specify that we want to do authorization regarding the connections that are coming into us that are using this profile, which in our case is going to involve all three of our spokes. And the syntax to do that is AAA authorization. I'm going to shortcut author just so I can get the full syntax on the screen. And we can do authorization based on a user basis or on a group basis. Now, if we do the user basis, we can actually use something called the name mangler, I kid you not, to go ahead and extract what the name is from existing content in a digital certificate. However, an easier way to do the authorization is based on the group and leverage the certificates. We can effectively say, if we've already authenticated this person with IKEv2 using digital certificates, that's good enough for me. So to complete this syntax, we're going to specify the keyword list and then refer to the method list that we created earlier for network authorization. And we called it author-list. And author-list is a method list for network authorization using the local option, meaning the router is going to do it on its own. It's not going to refer off to a AAA server. And the next piece here, let's use a question mark. Now in this part, if we were doing user authentication, we could go ahead and create something called a name mangler that would say, okay, based on the certificate, we want to pull the name from this portion of the certificate. For example, the common name or the organization name, etc. In our case, we're going to point to the authorization policy, which we're using the default authorization policy. So we'll simply follow up this command with the keyword default, referring to that default authorization policy. Now at the moment, we currently have functioning tunnels. But to change that, let's go to R2 and we'll go into configuration mode and we'll say interface tunnel 0. Instead of using IP unnumbered, let's do IP address negotiated. And we'll also do a clear crypto session to wipe out all of the IPsec and IKEv2 sessions that are currently in place between R2 and the rest of the world. We'll also go to R3 and do that same treatment. We'll go into configuration mode, interface tunnel 0, IP address negotiated, and then we'll do a clear crypto session there as well. And then on R4, the same thing. On R4, we'll go into configuration mode, then into tunnel 0 and say IP address negotiated, and we'll do a clear crypto session as well there. Now let's go back to R2 and see if we have any success. And now look at this, R2 is now back up. So in R2, if we do a show IP interface brief and take a look at the details for our tunnel 0 interface, check this out. It actually was the first one up, so it got the first IP address of 172.16.0.100. If we go over to R3 and use the same command of show IP interface brief, I'm assuming that it's going to have 101 as its IP address. And sure enough, it does. And if we go to R4, assuming that we're handing these numbers out sequentially, if we do a show IP interface brief, it's got IP address 172.16.0.102. And if we go back to the hub, back to R1, and give ourselves a little bit of free space here, and issue the command show IP route regarding OSPF learned routes, it knows about these subnets that R2, R3, and R4 have. And it also knows about those IP addresses, those interface IP addresses as 32-bit routes. And these virtual access interfaces that it learned them on were all created from the virtual template as clones, as it brought each one of those up logically to connect to the spokes. I have had a great time with you in this video. I'm glad you joined me for it. In your practice, if you want to use this document called Adding AAA Authorization and Pushing Configuration, that file is part of the Nugget Lab files for this course. What's inside of it are the changes we made to the hub, which is R1, the changes we made to the spokes regarding the negotiation of their interface address for the tunnel interfaces, and at the tail end of this document, I have the full running configs for R1 all the way through R4. That I saved once they were up and working. So feel free to use that as a reference. Again, thanks for joining me. I hope this has been informative for you, and I'd like to thank you for viewing.